Okay, my students, so let us try this again. This is ideal gas law take 2 because unfortunately my first video did not have any sound. So I have to record all 3 of my most recently updated videos again, and hopefully this time they will have sound. Okay, so let me get straight to it. So this video is going to be going over ideal gas law problems. So just to review, first let's write down the full equation for the ideal gas law. Ideal gas law, PV equals nRT. Okay, so before we go into the necessary calculations, let's kind of talk about some of these, or talk about these variables and what they stand for. Okay, so my first variable is variable P. This capital P stands for pressure. Okay, and within the ideal gas law, pressure can have several units. It can either be measured in atmospheres, ATM. It can be measured in millimeters of mercury, mmHg. It can be measured in torr, or it can be measured in pascals or kilopascals. Okay, it's a little bit big. Okay, however, for this assignment, since this is just covering some introductory calculations, to keep it simple, pressure is going to be using units of ATM. Okay, so let's go on to our next variable. Our next variable is capital V, and capital V represents volume. Okay, and again, volume can have different units. It can be units of liters, milliliters, centimeters cubed, or meters cubed. But again, to keep it simple, this the assignment that you're going to be doing, volume is only going to be measured in liters. Okay. So let's go on to our next variable. Variable N. So N just stands for moles. Okay, so there's nothing special on that. N is moles. And that's pretty much it. I mean, the units are there themselves. And just know that lowercase n is the moles of a gas. Okay. So next we're going to be looking at our next variable, which is capital R. So R is known as the universal gas constant. Okay, so depending on the units that you are using, there are different values of R. In this assignment, in this worksheet that I'm going to be giving you guys, the universal gas constant R is going to be 0.08216, and then the units are liters atmosphere per mole Kelvin. So if you have different units, then your gas constant is going to change. But for this worksheet, this is going to be our gas constant. Okay, so now our last unit is T, and T stands for temperature. Okay, so temperature has, at least in the sciences, 2 common units. It can either be in degrees Celsius or in capital K, which is Kelvin. So in the ideal gas law, we do want our temperature to be measured in Kelvin. So I'll just go down here. To convert from Celsius to Kelvin like that, capital K. So K your Kelvin is equal to your temperature in degrees Celsius plus 273.15. And that is just a constant unit of conversion factor, to convert from Celsius to Kelvin. Unless you are doing maybe in the AP classroom or in the actual lab setting, in the actual lab setting, you don't need to always include this 0.15. So you'll see me just round it to 273. So for example, if we have 50 degrees Celsius, to convert that to Kelvin, we just add plus 273. Okay, so 50 plus 273 equals 323. Okay, so now you have your temperature in Kelvin. Okay, so that's what we're going to be doing for the ideal gas law. Okay, and one more thing before we go into the calculations is this little handy dandy unit. What color haven't I used? Blue. Handy dandy units, or I guess unit you can say, known as STP. So STP stands for standard temperature and pressure. So at STP, your temperature is equal to 0 degrees. Okay, I confused myself. 0 degrees Celsius, which is equal to 273 Kelvin. And your pressure is equal to 1 atm. So in the event you have a calculation and it says it is at STP, standard temperature pressure, you already have your temperature and your pressure to work off of. Okay, so that's just a refresher on the ideal gas law and what the variables are, what they represent. Okay, so let's go into a couple sample problems. Okay, so let's first see what information has been given to us. It says, calculate the number of moles of a gas that is stored in a 75-liter container and exerts a pressure of 0.48 atm at a temperature of 50 degrees Celsius. Okay, so let's see. It says, calculate the number of moles. Okay, so we're looking for moles that is stored in a 75-liter container and exerts a pressure of 0.48 atm at a temperature of 50 degrees Celsius. So just like with some of our previous videos or previous work, whenever we were given a multivariable equation, we will, our first step is to write down all the variables for that equation in order to identify what's given to us and what is being asked of us. So it should look something like this. PV equals nRT going down. Okay, so let's see. First, pressure. In this example, I do see that the pressure is 0.48 atm. Okay, so we have pressure. It says volume. Volume I know is measured in liters. And I do have the value for liters, or for volume here, which is 75 liters. Okay, N, moles. Do I have anything for moles here? No. It says calculate the number of moles, so therefore this is my unknown. Next, my capital R, universal gas constant. Since it is our constant, it is going to stay the same as long as your units don't change. 0.08216 liters atmosphere per mole Kelvin. And finally, our temperature. We do have our temperature, however, it is measured in Celsius. So we just need to do a quick conversion, like I showed you previously, to convert that to Kelvin. I didn't even realize that we already did this calculation. I just chose a random number before. Turned out to be the same one from the example, so we already have the answer. Okay, so let's add the 273, and we get a temperature of 323 Kelvin. Okay? So let's see. So now our next step is, Our next step is to solve this. So let's start by rewriting our ideal gas law equation. PV equals nRT. Excuse me. Since I am trying to solve for n, right, because that's my unknown, that means I want to isolate n. I want to get n by itself on one side of the equal sign. So right now, I see that it's being multiplied by r and t, so I want to move it to the other side. So in order to get rid of that r and t, I need to do the opposite of multiplication, which is division. Okay, so it should look something like that. Okay, so when I rewrite it, n is equal to PV over RT. So I suggest you guys write this down. This will be one of the equations you might need. Okay, so the next, I will start by plugging in the values that we do know in order to solve. Okay. So N is equal to P, which is 0.48 ATM, times V, which is 75 liters, divided by R, which is 0.08216 liters atmosphere per mole Kelvin, times 323 Kelvin. Okay, so all you need to do to solve this, multiply the two values on top. So 0.48 times 75. Now please. 0.48 times 75 equals 36. Okay, let's remember that. 36 on top. And then on the bottom, 0.08216 times 323 equals 26.537. So let's round that to 26.54. Okay, so let's go back here. Hopefully you guys remember that top and bottom. N is equal to, on top, it was 36 divided by, oh, I asked you all to remember it and I forgot. 26.54, excuse me. 26.54 equals, so 36 divided by 26.54. Just doing it on my calculator I have right next to me here. So if I do that, it is equal to 1.36. Okay, so since we are looking for moles, our final answer should be measured in moles, but let's double check by way of dimensional analysis. So ATM cancels out with ATM, liters with liters, K with K. We are left with moles, which is the unit we are looking for. So then my final answer, N is equal to 1.36 moles. And there you go. Okay, so that is my final answer for this example. Okay, so let's go on to the next example straight away. Okay, my highlighter, let's change the highlighter color. So, okay. Second example says, determine the volume that would be occupied by 78 moles of oxygen at STP. So we are looking for the volume given 78 moles of oxygen at STP. So remember we talked about that handy STP, standard temperature and pressure, which means 0 degrees Celsius and 1 atmosphere. Okay, so let's start by writing our variables for our equation. Going down, PV and RT. Okay, so standard temperature, pressure we know is 1 atm. Temperature is 0 degrees Celsius, which is equal to 273 Kelvin, right? 0 plus 273 is just 273. Okay, we are also given 78 moles. We are looking for the volume. Volume is my question mark. And then finally, R is my universal gas constant. So for these examples, again, that is not going to change. Liters atmosphere per mole Kelvin. Okay, so then again, let us start by rewriting our ideal gas law to see what the equation is to solve for volume. I have PV equals nRT. I want to get V by itself, volume by itself, because that's what I'm trying to solve for. Right now, I see that it is being multiplied by P. So I want to get P on the other side of the equation. So to move it, I need to do the opposite, which is division. So V is equal to nRT over P. Okay, so again, I recommend you save, this equation. It's kind of silly there, but well, because you might be needing that one whenever you are doing your work. Okay, so now all we need to do is plug in and solve. So let's go ahead and do that. I'll do it here on the bottom. There's a little bit more space. So it's V is equal to N, which is 78 moles, times R, 0.08216 liters atmosphere per mole Kelvin. Get mamas. My dog is playing with her toy next to me. Okay, times T, temperature, 273 Kelvin. Hi guys. I know you want to play, but I'm working. I love you guys very much, but I'm working. Okay, in a little bit. Okay, divided by P, which is 1 atm. So for this example, since we are dividing by 1, we just need to multiply the 3 values on top to get our volume. Okay, so it's 78 times, and I will do this in the calculator I have right next to me, 78 times 0.08216 times 273. And a number divided by 1 is just going to be that same number, so let's not bother with that. So volume, volume is equal to 1,749.5. So since there is that 0.5, I will round it to 1,750. And again, to double check the units, atmosphere with atmosphere, moles with moles, Kelvin with Kelvin, we are left with liters, which is what we want for volume. So our volume here for the second example is 1,750 liters. Okay, so I hope that helps you a little bit solving these types of questions, my students. There are these 2 examples. I've already given you 2 of the necessary equations, right? To solve for moles, to solve for volume. So if you need to do the same thing, if you're solving for pressure or temperature, you just need to rearrange the same way. Okay, so hopefully this one has sound now. If you have any other questions, comments, or concerns, please let me know. You can always reach me through email. My email is m.valdez10@ljisd.com. Okay, so you can either send me an email there, or if you have the app which is Google Hangouts. You can download that and message me using your email address to my email address. Okay, so that's it for this video, my students. Enjoy the rest of your evening, and